Okay, good morning, everybody. Greetings from Finland. It's quite dark here. It's still early morning, but I know it's not so early for all of you. Some of you are here, I think, very early. So I heard from the Middle Europe. So today's topic is Introduction to Machine Learning for Oracle Database Professionals. My name is Helskyaho. I'm from Finland, known as Heli from Finland. I have graduated from University of Helsinki with a master's degree in computer science and currently working on my doctoral studies. I've been working with Oracle products for quite many years, and data and databases has always been my thing. And therefore, machine learning is exactly what I should be doing and what I enjoy a lot, because it's all about data. I'm a CEO for Oracle Finland Oy, Oracle ACE Director, Oracle Groundbreaker Ambassador, listed as one of the top 100 influencers in IT sector in Finland for quite many years, and a public speaker and author. I have written 3 books. First one about database designing, second one about SQL and PL SQL, and the latest one that came out this summer is about machine learning for Oracle database professionals, which is the topic today, by the way. So very briefly about machine learning. So what is machine learning? Machine learning is an important part of artificial intelligence. So artificial intelligence would be nothing without machine learning, seriously. It teaches computers to learn from experience using algorithms and the data. 1959, Arthur Samuel said that it's the field of study that gives computers the ability to learn without being explicitly programmed. And yes, it was 1959, so this is not a new topic, even though it's a very popular topic nowadays. It's a systematic study of algorithms and systems that improve their knowledge or their performance with experience. These are usually the definitions I use for machine learning, because when we talk about machine learning, people see it a little bit differently depending who's talking. So why am I talking about machine learning and why now? Because the environment we live now, it needs machine learning. And secondly, we are finally able to really use machine learning and all the cool things that have been evolving during these years. When should I use machine learning? When I have data. So data is the key in machine learning. It cannot be performed without data. When the rules and equations are complex, like maybe image recognition, or they are constantly changing, like fraud detection. So the nature of the data changes and the program must adapt to those changes. So these could be the situations for machine learning. But just remember, machine learning is not a silver bullet, and it's not a solution for every problem you have. Some real-life use cases could be spam filters, log filters or log alarms, data analytics, image recognition, speech recognition, medical diagnosis, robotics, all different kind of things that has something to do with data and using that data even better than you do today. Machine learning can be divided into categories. Unsupervised learning, and the most common method for unsupervised learning is clustering. Supervised learning, where the most common methods are classification and regression, and then reinforcement learning, which is also a separate part of machine learning. There are also things like self-supervised learning and so on, but I don't go to any new details on machine learning. I just go to the basic concept so that you will get some kind of idea what machine learning is about. This is clustering. So I said unsupervised learning, clustering. Unsupervised learning means that we have data that is not labeled, so we don't know what the data contains. So using clustering, we try to separate it into clusters that are similar to those entities inside the cluster and different from those on the other cluster. Classification means that we divided the data points into classes, like people who should get a credit card and people who should not get a credit card, or customers who will buy product A and customers who will not buy product A. So we are classifying our data into classes. So this did sound quite similar, right? So kind of grouping things. But actually classification and clustering are a completely different thing, because the difference is that in classification, we have predefined the classes. So we have already decided we will have cats and dogs, or we will have cars and bicycles and motorcycles. So we have already defined the classes. While as if we are using clustering, the clustering is identifying those things that are similar and those things that are different for each of our data points. So it identifies similarities and differentiations between those objects and groups them together into clusters. And the number of clusters is a hyperparameter. So hyperparameter means a parameter that is defined before we start the process. So we already defined there's going to be 2 clusters. So find something, a way to divide this set of data into 2 clusters. So we don't say it's going to be customers buying A or customers not buying A. We just say this is a data set divided in 2 using an algorithm. So that's the difference between these 2 quite similar sounding things that are very different actually. So another thing we do with supervised learning is regression. So this is how regression looks like. So we try to find some kind of trend in the data to predict what would be the value if X is 6, what would be Y? There are more complex examples of that, but this is just how to simply explain what we are talking about. So often you probably hear about deep learning. So what is this deep learning? Well, it's actually pretty much the same we just talked about, classification, but the difference is that in the traditional machine learning process, we have the input data, and after that we do feature extraction and then classification, and then we get the data if it's car or if it's not a car. In deep learning, the machine is also doing the feature extraction. So you don't do it manually. So that's the difference in short between these 2 things. So deep learning is actually doing feature extraction and classification automatically for you. So you just give the input data and you get the output data. And machine learning is doing everything in the middle. So deep learning can be used for complex things like computer vision tasks like face recognition or that kind of things, speech recognition, text recognition or text processing, all this kind of more complex things. But of course, all these need a lot of data and a lot of resources. So it cannot be done without having a lot of power. And one thing that is better today is that we have predefined data sets, pre-trained models, and we have things like transfer learning and many other things that reduce the need of these resources. One special case is convolutional neural networks. So I mentioned the neural networks. On the right-hand side, you can see neural networks, these crane things, and the input comes the dog picture. Then we have the neural networks, the gray ones, and then we have the output. Convolutional neural networks can be used with image recognition. So it's a convolutional layer on top of neural network. So we have these pieces, the pink, green, and red, on top of the neural network. So we have filters, we have output, and we have pooling layers, and then we flatten that information to neural networks. So this is one way of doing image recognition even better. I also mentioned reinforcement learning. So this is a very special case. So earlier I said that you need to have data before you can do machine learning. The cool thing about reinforcement learning is that it's building its own data. So while it's learning, it's also creating data. The thing works like this. We have an agent. We have an environment. And in this environment, an agent takes an action. Based on this action, the agent moves to another state in the environment. And based on how well the agent performed, it gets a reward, which can be a positive or a negative reward. So this is like a training a dog, if you can think about that. So let's think we have a car that it's trying to learn to park. So the agent is the car, the environment is the parking lot, the action is moving the car, the state is where does the car end up after the move, and the reward is how well did the move go. So if it's hitting another car, probably the reward is negative. And if it's managing to park to the right place, it's probably a very good positive reward. Of course, the problem here is how to define the reward. So what kind of reward function should we use? And how often should the reward be giving? After every step, if it's moving 1 inch, it should get a reward, or after it has moved, or how would it happen? So the problem with reinforcement learning is the reward function. So how to reward to make sure it learns the correct thing and it learns it as well as possible. The good thing is, of course, if we talk about the car parking, if we do it in a regular way, I would be teaching the car to park. The best thing the car can learn is to park as well as I do. But if the computer is teaching itself, the sky is the limit. It will be much better parker than I will ever be. So there are always good and bad things about everything, and also in machine learning. So now to Oracle. So what does Oracle offer for machine learning? A lot. Sometimes too much for people to get confused. So I was thinking we will see some examples quite quickly here. So first of all, I was thinking I'll explain you Oracle Machine Learning for SQL, because probably most of you know SQL and PL SQL. Then we see very quickly what is AutoML about, what is Oracle Data Science, and what is Oracle Analytics Cloud. First of all, if you want to go and try what I'm talking about today, remember that there's this always free service, which Oracle announced in September 2019 at Open World. So you can go and register Cloud Oracle.com and start for free. One of these resources that you will have for free is an Oracle Autonomous Database. And what I'm showing about SQL and PL SQL is there for free for you, because first of all, 2019 at Kscope 19, Oracle also announced that in the cloud, you will have Apex and ORTs automatically available in your autonomous database. So if you spin up an Oracle Autonomous Database, you will have Apex and ORTs available. Why? Well, Apex is an excellent tool for understanding your data. So you can visualize it, you can see your data, and so on. So Apex is a good tool for that. And ORTs lets you do many things. For example, publish your machine learning models to be used outside of your database. Which brings us to machine learning. So December 2019, Oracle announced that machine learning, spatial, and graph are all free of licenses. So if you have an Oracle database, like the free one I just showed you, you will have machine learning available for free. So this machine learning in database can be used for free in your on-premises database, in your cloud database, and also in these free tier autonomous databases. So why in database machine learning? Because of the data. I already said data is the key in machine learning. Why would you move the data? Because usually it is a lot of data that you are handling when you are talking about machine learning, and usually even your company systems, you have a lot of data. And you don't have any hassle moving the data because you just simply keep the data where it is. And the security issues, you don't have to worry about security because in the database, it is secured. But if you start moving the data outside the database, is it still secured? So there are a lot of things about moving the data outside from the database that are not good things. So keeping the data inside the database is a very good thing. Also, preparing the data is the hard part of machine learning. So a lot of articles claim that is 80-20% rule here. So 80% of the work is preparing the data for the machine learning process, and 20% actually is the machine learning itself. So hard to tell if it's true or not, but anyway, the fact is that a lot of work is spent on preparing the data. So preparing the data in the database is the easiest way of doing it because database is the natural environment for handling data. And also the skills that you need in the database, you already have them because you already know SQL and PL/SQL. So these are the tools you use for preparing the data. And also, as I mentioned, we have Apex there, which makes it easier for you to visualize the data and the process itself. And the deployment, because all we get here is tables, views, SQL packages, functions, procedures. So it is quite a natural way of processing. All these models that we build for machine learning are objects in a database, and therefore we have also data dictionary views. So when we start the machine learning process, it starts with defining the task. So what are we going to do with machine learning? And then understanding what does it actually mean? And maybe even fine-tuning the task to really understand what are we going to do. Then we collect the data and we understand the data. So what do we have in this data? We go through all the attributes. These are a little bit different words, attribute, feature, and column, but in this presentation, I use them as the same. So it means like birth date, name, address, street name, this kind of things, weight. So these are the attributes or features or columns. The next step is to prepare the data and transform the data so that the machine learning algorithms will be able to use the data. This all depends on the algorithms we are using and so on, but that's another topic. The next step is that we create the model. First of all, we decide what function we are going to do. What kind of function are we using? Is it going to be classification or regression, for example? And then what algorithms that are available are we going to use? All of them or just some of them? And then we evaluate these models. So if we created, let's say, 5 models, our job is to evaluate how did they perform, and then choose which of them is the best in our purpose. And when we have done that, we deploy the model that we chose to production. Okay, so this could be an iterative process. So we realize it didn't work, so we go back to defining the task or collecting the data or whatever, depending what we notice here. But this is the simple way of explaining the process. So first we define the task. In our example, we define predict the overall rating for a beer. Find the beers that will most likely be rated as 5. Find the brewers that most likely will make beers that are rated as 5. So for this kind of use case, we would use supervised learning and classification, and our target attribute would be overall. So we are putting these beers into classes 1, 2, 3, 4, and 5. Target attributes means the attribute column feature that we are trying to predict. This is a place where you can find all kinds of data sets, kaggle.com, and I have taken this data set also from Kaggle. So when we're doing supervised learning, the data must be divided in 2 sets, one for training and the rest of the data for testing that the model works. So we cannot use the same data set for training and testing because in training phase, the algorithm already saw this data. So it's already seen. We have to have new data to validate if the model works. And also the new data has to have known input and known output so that we can see how well it performs. Does it guess correctly or not? So that's why we need to divide the data set in two. In this demo, this is a super simple demo. Don't do this in production. This is just for demoing purpose. So we divide it in two sets, training data and test data. So when you divide, you have to divide, is it going to be 80-20%? Is it going to be 70-30? Is it going to be 60-40? What kind of division are you going to use? But the requirements anyway are, if we are using Oracle SQL machine learning, it has to be stored in a single table or view, which is called a case table. So we cannot have two tables and give those two tables to machine learning. They have to be somehow put together in one table or one view. Also, each record must be stored in a separate row as a case, and optionally, each case can be identified by a unique case ID. Well, if you're in a relational database, this should not be a problem. You probably already have a primary key. You have all your data in separate rows, and you have the possibility, if you have several tables, to create a view based on those tables. So now we are dividing the data into training and testing. This is a simple algorithm. This is probably not the best way to do it, but just to divide it in two data sets. The PL SQL packages we have in a database, there's three different packages that we use for machine learning. The first one is DBMS Predictive Analytics that has all kind of routines for performing predictive analytics, kind of simple machine learning. This is my own word for it. DBMS Data Mining Transforming, which has all the routines for those transformations you have to do for the data before the data is ready for machine learning. And last but definitely not least, DBMS Data Mining, which has all those routines for creating and managing the machine learning models. Predictive Analytics has routines for all kind of automated predictive analytics. You don't have to understand how model building and scoring works. All these activities are handled internally by the procedure. It has three things it can do. First of all, it can explain. This is a procedure explain, which ranks the attributes, how well they influence in explaining the target column. So how well does this particular column influence the way that we predict the target column? Then we have predict, which actually predicts the target column value. And then we have profile that generates those rules that describe the cases from the input data. This is how you call explain. You give the name of the table that you have the data. You say, what is the target column I'm trying to predict? And then you give a name to a new table where this result is stored. This is how it looks like. So it tells me that the attribute or the column taste has the biggest exploratory value for my target overall rating. So taste defines the best how it will be predicted. Palate, aroma, and so on are also predicting how well, or actually good predictors for the value. But let's say birthday, raw, or gender has no influence in the prediction. So actually, these that has rank 10 has no effect on the prediction. So actually, in the model, I wouldn't need this at all because they don't have any influence. They are just extra columns or attributes. So when you do the prediction, this is how you do it. So you call the predict. I have defined here accuracy as my metric. I have given the name of the table. I have given the primary key of the table. I have given the target column I want to predict. And then again, a table where I want to store the predictions. The accuracy here is not very good, so this is probably not a good model, by the way. What I get here is that beer number 1 will be predicted as 3 with a probability of 53%, and so on. So how well did it go? Well, actually, I'm not sure. Total number of rows was 37,000. correct predictions was 25 and not correct predictions was 12,000. Well, I'm not sure how it did because I haven't defined the metrics. So what do I want here? But these are kind of the data I got from here. The profile, I don't go to details here, but this is how you call the profile. So now to the process itself. So if you don't want to do that, you want to do the whole process. It usually starts with preparing the data. Well, actually also the previous should start with preparing the data because otherwise the data is probably not good quality enough for your process. We have different kind of attributes or features that we call here. We have data attributes that are those columns in a data set that you're going to use for build, test, and score the model. We have model attributes that are used internally by the model. So it probably doesn't use all the data attributes when building the model. It only uses those that are worth using. And then the target attribute I already mentioned earlier. So in supervised learning, this is the attribute, the column, the feature that will be predicted using the model. So identify these columns and then make sure you have them available. Understanding the data, you go through the data and attributes, features, you go through data types to be sure that they are the correct data type. Like here, palate and aroma, these were 1, 2, 3, 4, 5. It's actually not a number, it's a category. So make sure that you have defined them correctly so that the model will understand it's not a number, so it's a category. Type, expectation, missing values, outliers, maybe some comments about your investigation, maybe a linear plot to find data to be removed, outliers that are not correct, a correlation plot to show the correlation of data, remove nulls on significant features, transform features. So there's a lot of things you do while understanding the data. So in our example, the target was overall, but suddenly I find 0 value in overall, even though I just told you it's going to be 1, 2, 3, 4, 5. Should I remove it? Or should I define that actually the values are between 0 and 5 and not 1 and 5? So all these kind of things have to be considered and understood the business itself. Is a feature relevant? Is it independent? Like if I'm trying to predict the house price, the area of the house has probably some kind of effect on the number of rooms. So if I have 2 rooms in the house, well, probably it can be small or large, but if I have 5 rooms in the house, it cannot be actually smaller than a certain square feet, because we can't have 5 rooms in 20 square feet, let's say. So it depends on those, if it's independent or if it has some kind of dependency on other features. Is a feature simple? And how do you compare these features? So like GPS coordinate, it's probably not good because you can't say if one GPS coordinate is better than the other. But if you convert this to, let's say, for instance, distance from water, it has some value. So house that is by a water is probably more expensive than a house that is in the middle of the forest. So somehow transforming or converting the GPS coordinates to something more valuable for the machine learning process would be useful. In Oracle, we have a thing called automatic data preparation, ADP. If it's on, active, it automatically implements the transformations that are required by the algorithm so that the algorithm understands the data. And these are embedded in the model. So when you give a new data set to the model, it automatically executes all these transformations to the data set. So you don't have to specifically define it every time. It's automatically done for your data. Here are some examples, but I don't go to details on that. So I mentioned earlier, missing data is a problem. This is what ADP can handle as well. So first of all, the missing data, is it missing or is it sparse? Missing means that it's completely unknown. It's usually about simple data types. We just don't know this data. Sparse data means that we are assumed to know, even though it's missing in this particular row. And usually these are nested columns. So this is somehow possibly found out. So you can change how missing values are treated before you build the model. You can treat the missing data as sparse by replacing nulls using NVL function, maybe with NA value. You can treat sparse as missing at random by transforming the nested rows into physical attributes in separate columns. So you can change the way Oracle handles them automatically with these tricks. You can create nested columns if you want to include transactional data. You can convert column data types. So if you have age, you can change that to child or adult, if that's relevant to your machine learning process. Or you can do business and domain sensitive transformations like date of birth to age, if age is more relevant. You can do text transformations, but here's a limitation. If you have text columns, they must be in a table, not in a view. I mentioned earlier it's table or view. Here it's only table. Or you can write SQL expressions for transformations that are not handled by ADP. So data mining does form. It does binning, which means it's a technology for reducing the cardinality of continuous or discrete data. It groups related values together into bins so that the number of distinct values is reduced. It can improve the resource utilization and model build response times very dramatically without really significant loss of model quality. And it can actually improve the model quality by strengthening the relationship between these attributes. Normalization is a technique for reducing the range of numerical data. These are, you can check this later. These are the ways that Oracle can do them. Outliers I mentioned earlier. So outlier is a value that significantly is different from other values in that column. And the problem with outliers is that they can spoof, they can really twist the way the data is seen because they can be very, very different from the real values. They can interfere with effectiveness of transformations such as normalization or binning, we just talked about. So they can really mess your model completely. So the question here is this outlier value problematic, or is it perfectly valid data? And when you have an answer to this question, what should you do with that data? Should you keep it or should you delete it, or what should you do? In Oracle, there's trimming and winsorizing for that outlier treatment. So there's also transformations that you can do for on a record level. So this means that you take one column and you define how this column will be transformed. So you define an expression and a reverse expression if you go back to what it was before. And based on these records, you can build lists. So if you have several columns that you want to transform, you can add them into a list to have a transformation list. Well, there's different ways of doing it depending what version of Oracle you're using. This user-specified transformation list can be embedded as a transformation list in the model. And every time a new data set is applied to the model, the same transformations are done. So the very same thing I said about the automatic thing. So whenever new data set is used with the model, all these transformations are done automatically. So you don't have to define separate rules for test data or deployment data or whatever. It's always there automatically. And this is how you define it. When you create a model, you use X forms list to name the transformation list you're using. So what if you have both ADP on and you had defined your own transformation list? Well, the transformation list is embedded automatically, as I said, and it's executed before ADP. So when you create a model, you choose the mining function, you choose the algorithm, you create and populate the setting table. So here I choose the mining function. Do I use supervised or unsupervised? I use supervised, and I use classification because I'm classifying the beers. The next question is, what algorithms do I want to use? So depending on your Oracle version, you have different algorithms for classification. In my example, I only take 3: decision tree, naive Bayesian, support vector machines. Then first thing I need is a setting table. So the setting table has, when creating the model for my decision tree algorithm, I have to define certain things so that my model knows what to do. So I create a setting table for my decision tree model. And I define here that I'm going to use a decision tree algorithm. I can define here also other values, but this is a simple example. I only define this. It could be also definition of cost table and matrix, prior probabilities, class weight, and so on and so on. So these settings could be something else as well. But here we only use the algorithm, which is the minimal requirement here. So I'm now creating the model. The model name is going to be beer underscore DT. And I'm using a data mining classification, the classification of function. This is the table where I have the data. This is the ID index is the primary key. Overall is the target, and setting table I just created is called beer underscore settings DT. The model signature actually tells more about the model, what attributes were actually used when creating the model. I can also partition the models, which actually means that I can build and manage models for independent slices of data. So this is quite unique thing. So I can split the data into parts and use those as a partitioned model. Partitioning key is required and is set through setting table. So one of the rows I should insert into my setting table is this partition key. And they must be part of the using clause when scoring, but that's something I talk about later, so using. The next step is to test and evaluate the model. So I test the model with new data, known input, known output, and I evaluate it depending on the chosen metrics. So here I use my beer underscore DT model with a new beer underscore test dataset, and I store the result in the beer result table DT. This is what I get. So this beer 13803 will be predicted as 4 with a probability of something with a cost of something. It will be predicted as 5 with probability and cost and so on and so on. So depending what I want to measure, so what's important in my task depends on many things. It could be whatever, but this is very important to define. So how do I know which of these models I created is the best? It all depends on how we define what's its experimental objective. So in this particular experiment, what is important? For evaluating, you can use compute confusion matrix, compute lift, compute rock, rank apply, and so on. So this is another story, how to define which one is the best. So deployment is implementing the model in the target environment. So if I created the model in test environment, I have to find a way to deploy it into production. So I already mentioned that everything here is really database object. So the model is a database object. I can go and export and import that database model to my production environment. Real-time scoring, I can use my model beer underscore DT to predict what's the probability of beer 43548 to get overall rating 5. So here you see the using and star. This means that we are going to use all the attributes in this prediction. So it's not going to be number 5, very likely. I can also define just some of the attributes or columns here in the using clause. And now it's a little bit better if I only use style, but still not very likely that this beer will be of class 5. Then I can also do things like find me the brewers that will most likely have beers ranked as 5. So using the same model. If you don't like using these SQL packages, which you can use on premises, cloud, any tool that you can call SQL, you can also use SQL Developer's graphical user interface. It's a plugin that you can just install into your SQL Developer. This only works on premises. In the cloud, you have Oracle Machine Learning notebooks. And in these notebooks, you also have the AutoML, which I will show very briefly. So this is how notebook looks like any notebook in machine learning. AutoML, you sign in, you press the AutoML, and you start AutoML experiment. You press create, you define name of your model, where do you get the data, what kind of prediction are you going to do, classification or regression, what's the target attribute, what is the case ID. You can define additional settings. Now I chose classification, so I will see classification algorithms. I can choose which of them I want to use. You can also see all the features, I mean the columns in the table or the view. You can see how many percent nulls, how many distinct values, what's the min, what's the max, what's the mean, what's the standard deviation. And you can just unselect here those features that you don't want to use in your prediction, in your model. So you can then start creating this experiment when you have defined all these values. 2 ways of doing faster results or better accuracy. After that, it takes all the algorithms you defined, builds a model based on each of them, and using the metrics you chose, it ranks them here in order. So in my case, support vector machine and neural network were the best. I can always change that. I select the metrics and I can define here new matrices and then see them in that order. I can rename these models. Excuse me. So I can rename the model. So the model name is something logical because these names are just artificial names. I can go and see details in one particular model here. I can see the prediction impact. So which of my columns were impacting the prediction, and see on the right-hand side confusion matrix. I briefly mentioned confusion matrix earlier. So it's building that automatically for you as well. So you can use all this information to compare these models and then define which one is the best. When you have defined that, you can deploy the model here. You press deploy, you define name, URL, version, and so on. Or you can create a notebook based on this model, which means that you just build quite automatically the whole machine learning process. And you can document that by storing it as a notebook. You find it from notebooks. This is how it looks like. So just clicking those things, I built the whole process and I built the Python code. So as a beginner to either machine learning or Python or both, I can just learn a lot of things here by building it automatically with AutoML and then going and checking all my data, how the code looks like. So what kind of notebook was created. And of course, I can go and edit this and build even a better model if I want so. So the AutoML is based on Oracle Accelerated Data Science SDK, which is a Python library that's included in the data science service, but it's also used here in notebooks and in AutoML. So a friendly user interface with objects and methods that describe the steps involved in life cycle of machine learning model. Which brings us to OCI data science. This is not part of the free offerings, but if you start a new free tier, you get some extra credits that you can use to test data science as well, only in cloud. This is how the manual describes. Data science is a fully managed and serverless platform for data science teams to build, train, and manage machine learning models in the Oracle Cloud infrastructure. So this is actually for somebody who's very into Python, because you are able to pip install any kind of libraries in there. You find it from OCI here. The main concept is a project. Projects have notebook sessions. Notebook sessions can be open, edited, deactivated, or terminated. And this is how the environment looks like. So you have Python pre-installed, you have notebooks, and so on and so on. So it looks very much like any Python environment you might have been working with. And then Oracle Analytics Cloud, also not part of the free offerings, but can be used with credits. But there's also a desktop version, Oracle Analytics Desktop, that can be used for training and testing the tool. This is an excellent tool for understanding the data and preparing the data for machine learning, and I will explain you why. The manual says, analytics empowers business analysts and consumers with modern artificial intelligence-powered self-service analytics capabilities for data preparation, visualization, enterprise reporting, augmented analysis, and natural language processing. You find it in the cloud here, OCI, and then Analytics Cloud. This is my favorite. All the data sources you can use in Analytics Cloud is amazing. So you can take data from Snowflake, from Spark, from Oracle Cloud, Oracle on-premises, Sybase, Informix, any kind of data source. You can take that data, combine it together as one, and use it for machine learning. So this is the place to collect the data, put it together, process it, and then use it. The main concept here is Workbook. It used to be called Project, but the latest version calls it Workbook. The new release is coming probably next month, so I don't know how they will call it then, but now I will call it Workbook because the current version says Workbook. So the big thing is a workbook. This workbook has data sets, data flows, and sequences. In a workbook, you have the data to prepare, you can visualize it, and you can present. There's a lot of ways of preparing because there's augmented data enrichments like sensitive data detection automatically, geographic, demographic enrichments, transformations like dividing name column into first and last name, removing social security number, and so on. So it has a lot of tools for preparing the data as preparation scripts. There's a functionality called explain. So I have my target column here enrolled. I press explain, and it explains me the target column in detail. This is done using machine learning. I mentioned earlier already that I can take a lot of different kind of data and process it for machine learning. That thing is called create data flows. So I take a lot of data here. I join the data. I filter it. I do whatever I need to do with it, and I save it as a table in a database. And then I can build machine learning model on that data. Oops, sorry. Then I can also visualize it very easily, drag and drop and do all kind of visualization for it. And I can present, used to be called narrate. So I can present whatever I found from the data quite easily. So if I build the machine learning model using Oracle Machine Learning for SQL, I can register here those models I built, and I can use it with the data I have here in Analytics Cloud. Conclusions. Machine learning is here, and it will be here in the future. So this is definitely an area that should be paid attention, because if you want to be on business for long, this is probably something that will keep you busy. Oracle offers several tools for machine learning. And since you're already familiar with Oracle environment, this is not a huge step. This is an easy way to learn machine learning because I already know so much about machine learning. I said 80% is preparing the data. You have probably done that kind of thing for years already. So these tools I showed today, they can be used separately or together because of the database. So the data is there and can be shared with all these tools. And if you go to the OCI Oracle notebooks, in the same notebook, you can use SQL, PL SQL, R, and Python in one single notebook. So I think it's quite cool. So knowing Oracle technology gives you a head start. It's all about good quality data, which is something we've been working on for years already. So we know that already. SQL, PL SQL, R, Python. I don't see any excuses here. So I really recommend you start learning now, because this is, first of all, useful, and secondly, a lot of fun. Thank you very much for listening. Here's my email. If you have questions, you can ask now or you can ask later. I'm quite active in Twitter, and I have my blog. Thanks for attending. Any questions, happy to answer. Thank you.
Thank you very much for your presentation, Heli. Now we move to questions and answers. And I think there is one question from Alexander, and he's asking, does the prediction work if column value is JSON array, or it must be just primitives?
Well,
and I hope you can read it.
Yeah, yes. I must admit I have not tried with JSON. It depends on what you are using here. So, but what you can do with JSON is, anyway, you can create a view, which is then a relational way of seeing the data. So that at least is a workaround for that. But yeah, so the short answer is yes, you can work with JSON, no problem. But what is the best way of doing it depends on the solution you have taken. So what language you are using, and what tool are you using, and so on. But definitely yes.
Okay, thank you very much. In the beginning, Heli, you mentioned that you wrote books, and then at the end you said that you have a blog. I'm curious, how do you manage your time and find time to do so many things?
Well, actually, next week I will talk about this at this tour in Azerbaijan. So 26th of October, if you want to hear, there's a presentation called How to Have 42 Hours a Day. Because one of my friends says that you must have 42 hours a day because you do so much. And then I prepared a presentation. I have actually given it quite often at universities to encourage students. And then I was invited to give that talk also on this tour. So if you want to hear more about that, please come and hear my talk on the 26th. But yeah,
Okay.
my super secret is make fast decisions and be brave. That's another thing, because I have learned if you say no, because as a Finn, we are very shy. So if somebody asks me to do something, the first reaction as a Finn is to say no, because I am not the best in the planet, so I can't do it. So I have kind of relearned to say yes. So instead of saying no, I say yes. And then after that, I regret, why did I say yes? Because I don't know this thing. I have to learn so much. But that gives a motivation to learn.
Yeah, absolutely. Great. Thank you very much. I think we definitely will tune in to listen to your presentation soon, because very interested to know more about how you manage your time and, do so many things. And there is one question from Dilshod. He's asking if there is no mathematic model of business process or data management, then how should we do? How should we be? Something like that.
Well, first of all, machine learning is a lot about mathematics. So all this has mathematical base. So if you like mathematics like I do, this will be very nice, because like I mentioned, that when you are evaluating the models and you're trying to decide which one is the best, that's pure mathematics after you have decided what are important things, but the rest is mathematics. Also, all these algorithms are actually math. So there's a lot of math involved in the whole thing. But if you think about your own business and defining the tasks and defining how to define what is good and what is bad, what kind of metrics important. Like if you're trying to find people having cancer, it's much more important to find everybody who might have cancer and not be afraid of finding those who don't have cancer. So it's much better the person who doesn't have cancer will be registered as having possibly a cancer than not having cancer. Because if those people who do have cancer are listed as not having cancer, they will die because they are not treated. So depending what kind of use case you have, some things are important, more important than others. So sometimes false positive is not a bad thing. Sometimes it's really bad thing. So you kind of have to understand your own business and your use case. So what is important here and what is not important here. So defining the metric is probably quite a task in the beginning. I hope I answered the question. I'm not quite sure what it was, but I hope this was the answer.
Okay, thank you very much. And there is one more question, and it's in the chat. Heli, you can read it. It's from Alexander, and he's asking, are there free tools to replace OCI data science, at least during the learning of the topic?
Well, you can use it with the credits you get when you register for the free tier. So you can use it. I think it's worth $300 or something. So you can actually do a lot using that. Then you can also attend Oracle workshops. They organize some workshop with data science. And when they do that, they always give you the credits. So you are able to do the hands-on labs during the topic. But as I mentioned, this one particular library is the key of data science. So probably you can practice enough using just the notebooks, because if you just put there %mark and Python, you can call all these Python libraries that are part of data science as well. So a big part of OCA data science, you can also practice using the notebooks in the free tier. It's not the same because then you can't have your favorite libraries and so on, because it doesn't have all those things that you use Keras or whatever you do, like the data science has. So it's not 100% the same, but a little bit. You can get the taste of the special things. You can also use any Python environment and connect to Oracle database using cx_Oracle library. So that's also one way of doing it. So you can have whatever is your favorite. I have like 5 different Python environments in my laptop. So one of those, and then use this connection library to connect to Oracle database. And then you can use Keras or whatever you have. I hope they will give a free version of data science as well. It would be very nice. But at the moment, it's a payable option.